What if the universe isn't just a silent canvas of stars, but a storyteller? What if it speaks to us through light, darkness, dust, frozen worlds, and cosmic chance? The year 2025 became the year the cosmos spoke louder than ever. These discoveries didn't just surprise us, they reshaped how we see life, matter, and time itself. What you're about to hear are 7 stories echoing across billions of years, chronicles of distant planets, newborn stars, silent giants, and living quiet. Listen closely. This isn't science fiction. This is the universe as it is right now. We are used to seeing stars as distant points, as eternal beacons of the dark. But imagine what if they whisper, like ancient witnesses about their birth, death, and the secrets they've guarded for billions of years. What if the universe is not a static space, but a living organism breathing, moving, changing? The year 2025 brings us stories we've never heard before, stories you can almost hear. Now, I'll take you through 7 such tales. Dramatic, wondrous, dark, and luminous. Buckle up, we're taking off. Deep in the center of our galaxy, 27,000 light-years from Earth, lies a giant molecular cloud, Sgr B2. It is one of the densest star-forming nurseries in the Milky Way. With the help of the James Webb Space Telescope, scientists were able to peer inside this dusty giant and discovered stunning details. Hot pockets of gas, stars not yet broken free from their dusty cocoons, and organic molecules, including methanol and complex ethers. The cloud's mass reaches 10 million solar masses. Though only about 10% of its volume participates in star formation, that 10% produces nearly half the activity in the region. But it's a fierce battle. Some parts of the cloud collapse and give birth to stars, while others are destroyed by the radiation of stars already born. We're witnessing a true gravitational radiation drama tens of thousands of light years away. Now, let's jump to the outskirts of the solar system, to the dwarf planet Makemake. A cold, distant world, hidden beyond Pluto's orbit. For a long time, it was believed that nothing active could happen there. But in 2025, the James Webb Telescope detected a faint infrared glow above the planet's surface. Spectral analysis showed the presence of methane in gaseous form, which means Makemake is breathing, or at least it's venting ice from its interior, perhaps through microfractures. There are 3 possible explanations. A weak internal heat source causing localized melting, leftover ices sublimating under solar radiation, or remnants of past activity preserved as slowly evaporating deposits. This discovery forces us to reconsider the boundary between geologically dead bodies and potentially active ones. Now, a truly rare visitor. The interstellar object 3, I divided by Atlas, only the 3rd such traveler ever detected from beyond our solar system. It is not bound to the Sun and follows a hyperbolic orbit, meaning it came from interstellar space. Its nucleus is about 11 kilometers in diameter. The comet's coma, the gas surrounding it, is mostly composed of carbon dioxide, which is extremely unusual. The CO2 to water ratio is 8:1. For comets, especially first-time visitors to the inner solar system, this is an anomaly. The coma stretched nearly 350,000 kilometers. Such behavior points to a different chemical makeup, a place of origin where frozen CO2 was more abundant than water. Scientists believe the comet formed in an ancient star system, possibly over 7 billion years ago, and only now has it reached us. It's a letter from another galaxy, literally, and we are reading it. We now descend to Saturn, to its moon Enceladus. Beneath its ice lies a global ocean. In 2025, scientists detected fresh organic compounds in the geyser plumes erupting from fissures at its south pole. These compounds had not been exposed to strong cosmic radiation, suggesting they were just ejected from the moon's depths. Moreover, there is evidence of hydrothermal vents inside the ocean, chemical gradients similar to those on Earth that support entire ecosystems around underwater volcanoes. Enceladus is becoming one of the most promising places for life in the solar system. And this is no longer just a hypothesis, it is a research direction backed by data. Now to a mysterious galaxy tentatively named the Galaxy of Infinity. Its shape resembles the infinity symbol, but what's happening inside is even more important. At its center, massive gas clouds are collapsing directly without first forming stars. This means a supermassive black hole is forming directly without a long accretion phase, without growing from a small black hole. This confirms the theory that in the early universe, just a few 100 million years after the Big Bang, supermassive black holes could form rapidly through such direct collapses. Galaxy Infinity is a living example of this process in action. The Euclid mission, launched by the European Space Agency, delivered in 2025, one of the most extensive observational catalogs of galaxies. More than 26 million galaxies, 500 new gravitational lenses, and dozens of Einstein rings, perfect arcs of light formed by massive objects. These lenses let us see galaxies that would otherwise be too faint, magnifying their images and showing us events from 10 billion years ago. But most importantly, these lenses allow us to map dark matter. We don't see it, but we see how it bends light. Thanks to Euclid, we're getting a three-dimensional map of mass distribution in the universe. And that map tells us our picture of the cosmos is still incomplete. And finally, Mars. The red desert we long believed to be dead, but the Mars Trace Gas Orbiter is detecting otherwise. At an altitude of 40 kilometers, icy clouds, below layers of dust, over the poles, seasonal ozone vortices. This means the Martian atmosphere is alive, breathing, however faintly. Moreover, the mysterious dark streaks on Martian slopes, the so-called recurring slope lineae, are now thought to be caused not by water, as previously believed, but by dust flows or subsurface emissions. Yet the presence of ozone is significant. It blocks ultraviolet radiation, which means it could protect organic compounds if they exist. Mars is not dead. It is simply very, very quiet. So, in just 1 year, the universe has told us of stars being born in dusty clouds, of distant icy bodies breathing, of messages from other star systems, of oceans beneath ice that may harbor life, of galaxies becoming black holes, of light distortions revealing dark matter, and of Mars, where seasonal chemical dramas unfold in the thin air. The cosmos is not silent. It speaks, and with each year, we hear it more clearly. We've long believed space to be silent, but it's not. It speaks in the methane haze of a distant world, in the birth of stars wrapped in dust, in the shadows moving across Mars. With each passing year, we hear it more clearly. And maybe, one day, we'll realize these aren't just observations. They're invitations to explore, to understand, to begin a dialogue. The cosmos is speaking. All we have to do is learn to listen